Alright, now that we talked about the product rule, the next thing we want to discuss is the quotient rule. Now again, for the quotient rule to work, you have to have the same index on them, just like the product rule. So if you have nth root of a and nth root of b as real numbers, and b cannot equal 0, and of course your n has to be a natural number, then you can say that if you have a radical of this form where you have nth root of a over b, you can break it down into nth root of a over nth root of b. Okay, so you're basically just splitting up your fraction here into two radicals, or as a quotient of two radicals. Now, since you can see that you have your nth root of b in the denominator, that is why your b cannot equal 0, because again, you don't want your denominator to be 0, that will be undefined. So let's go ahead and apply our quotient rule here to this example. Again, remember, if you see any variables, the variables are all positive real numbers. So just like your quotient rule says, we can go ahead and break this up into square root of 3 over square root of 25. Now we know square root of 3 cannot be simplified any further, so you leave it as it is. Square root of 25 we know is 5, so you go ahead and simplify that, and that's how far you can go with this example. Square root of 3 over 5 will be your answer. Let's look at a couple more examples here. Now here you have cube root of t over 125. Okay, so again we will use our quotient rule to go ahead and split our numerator and denominator, so you should end up with cube root of t over cube root of 125. Now again, cube root of t, you cannot simplify that any further, so you leave it as it is. And what can you simplify cube root of 125 into? Now just like square roots, again remember, cube root says what number multiplied into itself 3 times will give you 125, and that number will be 5. And that will be your solution to this example here. Okay, now let's go ahead and look at another example. We have fifth root of the quantity 32 over y to the 20th. Again, go ahead and split up your numerator and denominator. So you end up with fifth root of 32 over fifth root of y to the 20. Now, fifth root of 32, again, you're trying to find what number multiplied into itself 5 times will give you 32, and that number has to be 2. Okay, so if you take 2 to the 5th power, you'll come back to 32. Now for your denominator, you have fifth root of y to the 20th. Go ahead and change that into a rational exponent, so you will end up with y to the exponent of 20 over 5. And you can go ahead and simplify this rational exponent now, and that will give you 20 over 5 will of course reduce down to a 4, and you will end up with 2 over y to the 4th as your solution. So you can see what we learned in 10.2 will come in handy here to help us simplify these radicals here. Now let's go ahead and look at one more example on, and this time we're talking about the negative fourth root of 625 over y to the 4th. Again, notice the negative is outside the radical, not inside. So we'll go ahead and carry that forward with our answers. Again, go ahead and split up your numerator and denominator using the quotient rule. And you'll see we end up with fourth root of 625 over fourth root of y to the 4th. Again, bring your negative first. Fourth root of 625, again, what number multiplied into itself 4 times will give you 625, and that answer will be 5. Okay, For your denominator, you can again write that as a rational exponent. So you end up with y to the 4 over 4. And now go ahead and reduce the rational exponent, which will give you 1. And y to the 1 is the same thing as y. So you will reduce or simplify this expression down to negative 5 over y. Okay, so basically you can see how you can use the product rule and the quotient rule to help simplify radical expressions.